Assalamualaikum. We are from 2BMFG. We will present about the element of power system. Uh, this is this is my fellow member Aina Shamira, Nurul Nisa, and Miss Tina Hidayah. So the element of power system, as you can see at the slides, there are the flow from the power plants to the step transformer to the tower, which to the transmission substation, distribution substation, transformer, and home, which is consumer. So power system is the network of electrical components that deployed to supply or transfer or store and use electric power. So as we know, the main element is power plant such as a generator, transmission, distribution that distribute the load, and transformer, and lastly is consumer. So the first one is generator. Generator is the device that converts mechanical motion into the electrical power. The power that has been converted will transfer to the transmission and distribute over power line to the consumer. As you can see above, that is simple as a generator. So this we use the concept magnetic field. So when the motion are parallel to the magnetic field, there are no voltage produced. But when the motion perpendicular to the magnetic field, the magnetic flux will be produced. So the electric will be produced. So at the besides is the generation. As we knew, there are renewable and non-renewable energy source. So for the non-renewable energy source, there are four there, which is coal, oil, gas, and nuclear. And for the renewable energy source, as hydro or wave, solar, and wind. So this generation will, as for non-renewable, it will go to power station for the process, and then go to turbine, and then go to generator, and will be transferred to the transformer. For the renewable, it will directly go to generator and go to transformer. So for the non-renewable energy, there are advantage and disadvantage. For non-renewable energy, the advantage is the source was cheap and most easily to get. And for the disadvantage is the source will produce carbon dioxide gas when the source are combustion, and the gas will contribute to the global warming. The second one is produce oil slick and pollute the beach and harm the wildlife. So for the renewable energy, the advantage is the source is sustainable and will never run out. The source also requires less maintenance because it is natural for the environment, and it also minimal the impact on the environment because it was natural. And lastly is it bring economic benefit to regional area because the source we don't need to pay. So for the disadvantage is, for this source, it's difficult to generate a large quantity of electricity, and the supply also reliability, and to the current cost for the renewable energy is also large.
Next, we go to the transformer. The definition of transformer is electrical power transformer is a static device which transforms electrical energy from one circuit to another without any direct electrical connection and with the help of mutual induction between two windings. It transforms power from one circuit to another without changing its frequency but may be different voltage level. We can see from this picture above the conjunction with high magnetic permeability of transformer can be designed to efficiently change AC voltage from one voltage level to another within power network. This is the type of transformer. We can see First is generator transformer. This is the generator transformer. Generator transformer are critical link between the power station and the transmission network. Next, for the station transformer, the station transformer are used to supply power to 11 kilovolt drive. Meanwhile, the grid is connected to the same block through the station transformer, which is 400 kilovolt or 11 kilovolt transformer. Next, the distribution transformer. This is the distribution transformer, which is service or is called service transformer, that provides the final voltage transformation in the electrical power distribution system. Next, the fourth is unit auxiliary transformer. Unit auxiliary transformer is the power transformer that provides power to the auxiliary equipment of a power generating station during the normal operation. Next, the instrument transformer. The instrument transformer is to operate instrument for metering from high voltage or high current circuit. It is safely isolated secondary, which we know that is controlled secretly from high voltage or current. The lastly is rectifier transformer. Transformer is a transformer that includes diode or thyristors in the same tank. This picture we can see it is in always it is in industry. Next, the transformer we can see it have a step up and step down transformer. For the step up transformer, it is most secondary winding turns than primary winding turns. It's called step up transformer. For the step down transformer, it conversely a transformer designed to do just the opposite, that's called a step down transformer. From the picture above, we can see from power station it produced the low voltage went to the step up transformer. From the step up transformer, it used the high voltage to the step down transformer. From step down transformer, it produced the low voltage and went to the consumer.
The third element is transmission line. Transmission line is a long conductor with special design. Basically, in Malaysia, we use HVAC, which is high voltage alternative current, for transmission line. There are 4 parameters, which is resistance, is inductance, capacitance, and conductance. The purpose is to carry good amount of generator power at very high voltage from one station to another, connecting radio transmitter and receive with their antennas, distributing cable television signal, trucks line routing point between telephone switching and center. This is the element line before step up transformer. Step up transformer will increase the voltage for long, so it can travel long distance over high voltage transmission line. Okay, there are 4 types transmission line, which is 2-wire line, coaxial cable, waveguide, and planar transmission line. This is the diagram of the type. The type 2-wire line, coaxial, and microstrip. Microstrip is referred to planar transmission line. For the component at the transmission line is conductor, earth wire, insulator, transmission tower, wave track. At transmission line has three type of distance.
short transmission lines, medium transmission line, and long transmission line. At the short transmission line, length is about 50 km and the voltage up to 20 kV and capacitance effective is negligible. At medium, the length is about 50 km to 150 km and the voltage is from 20 kV to 100 kV. Capacitor effect is present. For the long transmission line, length is more than 150 km. Water level is about 20 kV. Distribution system. It is consists of network overhead line and underground cables. The distribution system is the final stage in the delivery electricity power. It also carry electricity from the transmission system to individual consumer. It is connect to the transmission system and lower the transmission voltage to medium voltage. There are two distribution which is primary and secondary. The primary is carry this medium voltage to distribution transformer and locate near to consumer premise. Primary distribution voltage range about 4 kV to 35 kV phase to phase, and primary is referred to large industrial user. Okay, the secondary is electricity is delivery at a frequency of either 50 or 60 Hz depending on the region. Next, for load, the utilization of electric power is collectively called load. This includes the use of electricity in homes, factories, offices, and for recreation, entertainment, and etc. For the phase, there is two, which is single phase and three phase. The load for the single phase is 240 volt, and for the three phase, the load is 415 volt. Thank you. Video minit.